Hi everyone, I'm Steve, and in today's project I want to take a look at accessing the hidden and internal USB components that are often found in modern computers. This is my Intel NUC. I'll be demonstrating my technique on this computer today, and you might remember this from a previous video where I violently tried to shake it off my monitor. Okay, here we go. But that aside, I found that I'm running out of USB ports for my utilization. This machine has 5 external USB ports. There are 2 on this side for USB Type A, plus the Thunderbolt USB-C port, and on the opposite end, there is another USB-A port and another USB-C port. I'm even using one of those 4-port extenders that goes into one of the Type A ports, and with that device, I'm often running out of USB ports for my type of usage. I often find that I have to use one of these Type C to Type A connectors, and then that means I have to lose the nice capabilities of either the USB port or the Thunderbolt port. It's just not feasible. But inside this device are 2 hidden USB 2.0 ports, which will become very handy if I can just get access to them. If you've ever assembled a computer from its individual components, you may have realized that there are some ports on the motherboard that go unutilized. That is, they just don't connect to anything on the chassis or any internal peripheral. The first step to identifying such ports is to check your BIOS for features that are unexpected, and then to reference your manufacturer's technical documentation to see exactly what those things do. Let's take a look at Intel's documentation for this Intel NUC product and see what it says about the internal USB ports. This is Intel's technical product specification for the NUC product that I own. Now, unless a manufacturer doesn't want you tampering with your hardware, you should be able to find this type of documentation for pretty much any modern or recent computer. In fact, I was able to do it for an old computer that I had back in 2007 that was manufactured by Dell. If we move ahead to the preface of this document, we can pretty much see exactly what it's designed for and its intended audience. And basically, people that are interested in learning more about their hardware and what it can do. But what I'm interested in is this, a map of all the resources on the motherboard. Now there are 75 pages in this document. I'm not going to read every single one of them or even go through them, so I'm going to skip ahead to the relevant portions for this project. Here's an overview of the connectors and resources on one side of the motherboard, and what I'm interested in are these 2 little guys down here in the corners, F and G. And moving along to the next page, we get an overview of what all those connectors are, but F and G are the internal USB connectors that I want to utilize and expose. Now, reading carefully, this is a 1.25 millimeter pitch header. That's not a micro USB connector or a mini USB or USB-C or anything that we're probably familiar with. So to get more information about exactly what Intel used to expose this USB port, we have to, of course, read further in the document. Unfortunately, the next page gives us a little bit more useful information. We get a pinout of the connector on table 15, and we can see exactly how we can map it to a standard USB Type A connector that will sit on the outside of the machine. And furthermore, Intel gives us a part number that they used for the USB connector that is on the motherboard. This is a Molex PicoBlade connector, which has, of course, the 1.25 millimeter pitch, and we get this part number, which we can use to order directly from Molex if we wanted to. However, when I researched this part, I found some interesting information on Wikipedia. If we read about the JST series of connectors, which are a little bit more common in my use, I found that the GH connector has a 1.25 millimeter pitch, and it's also listed as being somewhat compatible with the Molex PicoBlade connector. So can we use a GH connector in place of the Molex PicoBlade connector? Well, the answer is yes and no. Yes, you can plug them together, they'll fit, but no, you wouldn't want to do it on an airplane's autopilot system. It really doesn't instill confidence. So depending on your use, this might be a viable solution if you cannot get a hold of the Molex PicoBlade connector, or maybe if you had JST GH connectors on hand already. So back to our document, Intel tells us to see this section for more information on the USB 2.0 header, and when we go there, we get a very nice picture describing exactly what the pins are on the terminal and their pin assignment and where they are located on the terminal as well. This picture is showing that the pins are recessed to the left side of the motherboard side of the USB connector. So that gives us the perfect alignment that we need to map each of the USB 2.0 pins to the cable that we can manufacture. And what's really nice is that the 5-volt pin on the USB header is fused. That means if I were to accidentally put a short between pins 1 and pins 4, then the fuse is going to trip and it's not going to blow up my motherboard. Alright, we have all the information we need now, so let's get a hold of some parts and try to build a cable. And this is all we need to build this cable. Really straightforward. We have the Molex PicoBlade cable that will plug into the motherboard. This could be a JST GH terminal. I don't know. I bought it off an eBay seller who claimed it was Molex. I'll take his word for it. It does fit, and it also fits into the male ends that were provided with this cable, and they look pretty much like what's into the motherboard. Now, I opted for the pre-wired version of this cable because these are really small, and there's no way I'm going to be able to solder those terminals to these wires if I had to do that. The USB side is just as straightforward. This is the standard USB 2.0 female end, and the terminals have a slight recess in them, so it'll make soldering the ends of these wires to these terminals very straightforward. The only thing tricky about this is to figure out which wires need to be soldered to which terminals. So let's start with the familiar end, which is the USB side, and I remember this by holding the female end so that the plastic part of the connection is facing upwards. And then the terminals are enumerated 1, 2, 3, 4 from left to right. And that translates to plus 5 volts, D minus, D plus, and the ground, where the middle two are the data connections. So then we go over to the male side of the PicoBlade connector. And Intel has done a nice job and shown us that the pins are on the left side in their diagram. So they're recessed as far as they can go inside the terminal. And if we look at this, I'll try to get this into focus, then that's going to be pin 1, pin 2, pin 3, pin 4, top to bottom, which of course translates to V plus, D minus, D plus, and ground. So all we got to do now is try to fit this cable into this slot, and it will fit somewhere like that. And therefore now we know the colors that we need to map to the terminals on the end of the USB connector. As I was preparing to solder this USB terminal, I noticed that the plastic enclosure isn't going to put much compression on the cable once it's fully attached to it. You can see there's still quite a bit of room there, even though it's not fully sealed, and the wires that go in here, they can pretty much wiggle around. There's quite a bit of space for them to move freely. So I'm a little concerned about the strain relief that we could potentially put on here. It's effectively non-existent. So to help out with that, I put a little bit of heat shrink tubing on the wire ahead of time. I think what I'll do is I will have this slide up and it will rest somewhere in here. And so when this closes, the wires will be kind of bunched together and they won't be easily tugged out of the position. And then finally, I'm going to use a bit of Kapton tape to seal the terminals around the wires once everything is soldered in place. That's not foolproof, but it should provide a little bit of protection against somebody tugging on the end of it unnecessarily. So let's go ahead and get this thing soldered together. My USB cable is ready, but I don't want to plug this into my computer right away. I don't know if I created any short circuits between the terminals on this end and the terminals on that end, or maybe even the terminals amongst themselves. So to test that out, I'm going to use my multimeter and validate the continuity between opposite ends of the cable and make sure that there's no continuity between sibling or parallel ends of the cable. I won't be able to get my multimeter probes into that female end of the USB side, so I have a male terminal which I'll just plug into here, and now the leads are exposed and I can test continuity between opposite ends very easily. So let's get the multimeter activated. Let's do a quick test to make sure the leads are set up correctly, and let's start checking to see if there's any shorts between each of the terminals on the USB side. So far so good. What was that? Oh, I bridged the two accidentally. And I think I've got them all covered. This should be fine. Yep. Okay. All looks good. Now the opposite ends. So we'll start with pin 1. And I recall that pin 1 is the red wire. So that should buzz, and it does. And none of the other ones should buzz. And that's good. Now pin 2 is the black wire. And that looks good. None of the other ones should activate, and that's correct. And pin 3 would be the yellow one. And that's correct. Nothing on the opposite ends. And finally the ground is the white wire. And that is good. Of course, none of the other ones are activating as well. And just as a sanity check, I'm going to probe each of these pins on the Molex side and make sure that this cable, or this terminal block on the Molex side is correct and not shorted out. It's going to be a little bit difficult since it's really small, but I'll do my best. Okay, that's fine. It's fine. It's fine. It's fine. And then these pairs. It's okay. Those ones, I think I've got all permutations covered. Yeah. Okay, this looks pretty good. Let's give it a test on the computer. So to connect this cable to the motherboard, we're going to have to figure out a way to get it inside this box. And I was looking along the sides of this computer, and I noticed that the easiest way to get this in here is to route it through this lock port. I'm not planning on locking this thing anytime soon, so this is a perfect way to get the cable in there for my use. There are a couple other ways to do it as well. The lid to these computers is removable, and you can see that along this edge there's a little perforation where you can put a little tool in there and ease the lid off. So with these types of cables that are fairly flat, it's pretty straightforward to route the cable through here and then into the motherboard and connect it accordingly. Another option you have is to print your own lid for the Intel NUC. Intel provides CAD files on their websites, and they actually encourage people to develop these types of lids for expanding the use of this type of computer. And finally, if you don't want to go this route of building a cable and hooking it up to the motherboard, you can get a product made by GoRite, which I'll link in the description below. It basically replaces the entire lid and exposes the two USB ports directly on the top of the lid. So to route this cable through this tiny hole here, we'll first have to remove the back of the computer and access the motherboard. And this is what the motherboard looks like on the inside. The USB headers that we're interested in are on the right side. There are these two ports next to the M.2 connector, and we'll just route this guy in through the side and plug it in to there. Now I've taken the liberty of making a second cable because I want to utilize both of those ports, so we'll go ahead and connect both of these things to the motherboard right now. And with that done, let's get the cover back on and give these two new USB ports a test. Well, that didn't work out because I apparently had forgotten how locks work. I had my cables routed through the lock port hole and into the motherboard connectors over here, but I had forgotten that the cover that connects over here also has a lock port hole, and I didn't route my cables through that, which means that if I had forced this thing on and closed it together, then this piece of metal here would act as a guillotine and damage the cables. I thought I might be able to route my cables through here and then into there, but they're just not long enough to have enough slack and reach all the way through here safely, such that if I had ever needed to open this case up, I didn't have to finesse this thing up and try to disconnect, connectors while it's sitting about this high off the case. It's just not practical enough to do that. So on to plan B, because that did not work at all. Plan B involved routing the cables through the opposite lid via these depressions on the plastic side. But again, they're just not long enough. I tried getting it through here and then through the side of the case over here and then into the connector over there, but it was about 2 centimeters short to do anything practical with it. So it was incredibly frustrating. But not all is lost. I can still route my cables through this side of the case and have them appear out of this corner on this end. I tried with one cable and the case lid closes properly. There aren't any problems with the case lid closing at all. So I'll take that approach and we'll try to put this thing together one more time. Alright, it's time to give the computer a final test, and I've jerry-rigged some kind of a test harness here. Not everything is going to be in shot, predominantly the monitor, because it's way too big to fit in shot with the computer on the desk and the keyboard and the mouse. And I think the important thing is to see that these three things are going to be operating in unison. So the first thing we'll do is we'll power things on and make sure everything works. Alright, so far so good. Things are booting up. No problems there. Alright, and here's my login screen. I think the first thing I'll do is hook up my mouse. Let's see. Let's put this one in this port. Okay, now my mouse has received power, and if I move it around, good. The data is transmitting. I can click. Everything seems okay, but I'm not going to be able to log in because my keyboard's not hooked up. So let's do that. Put this in the other port. And you might not be able to see this, but my keyboard is receiving power. The numlock key is on. And let's enter in some bogus PIN because I don't want to share my passwords to the internet. And so far so good. Everything is working. Let's try some other keys. Yeah, everything looks good. So I think this is pretty much a success. Now, one limitation to this type of hookup is the amount of power that these leads are going to be able to provide. This is a USB 2.0 connection, so it's going to be limited to 500 milliamps maximum. So keep it to 500 milliamps or less. Mice, keyboards, video cameras, always a good shot. Hard drives, not a good idea. So that will wrap things up for this video, and as always, thank you for watching, and I hope you find this information useful. Please feel free to add your comments to the discussion below, and to use the like and dislike buttons at your leisure. Don't forget to subscribe for more content, and I hope to see you back soon.